Hello and welcome to Mech Zone. In the previous lectures, we have already finished with the velocity and acceleration analysis, and from this lecture onwards, we shall be starting with a new chapter, that is gears. And in the gears, we first have to discuss about the phenomena of slipping. For example, we have one body having a radius r1 and rotating with angular velocity omega 1. Another body is having a radius r2 and it is rotating at an angular velocity omega 2, such that the common point which is lying on both these bodies is actually called as the point of contact. Okay, this is the point of contact, and at the point of contact by body 1 we have r1 omega 1, and at the point of contact we are also having the body 2, so by body 2 we have r2 omega 2, and these two quantities are actually equal to each other at the point of contact, and hence there will be no slipping. There will be no slipping at the point of contact if r1 omega 1 is equals to r2 omega 2, such that omega 1 upon omega 2 is equals to r2 upon r1, and this ratio is actually a constant. Okay, this ratio is actually a constant. Now if we talk about the static friction, or if we talk about the friction, then friction is obviously there. The value of friction is not 0. The value of the static friction is actually lying between 0 and mu n. It is lying between 0 and mu n, which is actually seen that it is variable in nature. That means it can vary between 0 and mu n. Why? And we see one more important point here, that static friction is there. Why static friction is present? It is because of the tendency of motion. Because of the tendency of motion, the friction is present here. So if we see that there are no losses of energy and the drives where slip is possible, then those drives are called as negative drives. So the drives in which their slip is possible, such drives are called as negative drives. And for example, the example of belt negative drives are belt drive, rope drive and chain drive. Okay, where chain extension is actually taking place to a certain extent. Now what are the advantages of these negative drives? First is they are durable, second is they are cheap, and third is they are easy to maintain. So easy maintenance can be done. Whereas in some systems, where if we talk about, very high accuracy is demanded for power transmission. Okay, in some systems very high accuracy is demanded for power transmission, hence the ratio of omega 1 upon omega 2 should be constant. The ratio of omega 1 upon omega 2 should be constant. And those systems in which the slipping is actually impossible, such systems are called as positive drive, or in general we will call them as gear drive. Okay, but these are very costly. Okay, where positive drive, where slip is not possible, such are called such will be dealing with gear drives, and gear drives are quite costly. Okay, if we closely look at these systems, these bodies are actually called as gears, and we see that these gears are actually having these types of projections on their surfaces, and these projections are also called as teats. These projections are called as teats. So this was corresponding to the first body and this is corresponding to the second body, and the plus represents the center of these bodies. So actually the center is represented by plus, and if we look closely, the outer surface or the peripheral surface is actually composed of these structures called as teeths. And we see that minimum one interlocking between the teeths is always present. Minimum one interlocking between teeths is always प्रेजेंट. हमेशा मिनिमम एक टीथ तो हमेशा कांटेक्ट में रहेगा ही. हेंस बिकॉज ऑफ दिस द स्लिपिंग इज इम्पॉसिबल एंड हेंस इट बिकम्स अ गियर ड्राइव एंड इट इज वेरी वेरी कॉस्टली. ओके, नाउ वी विल ड्रॉ और आई विल ड्रॉ द स्ट्रक्चर ऑफ दिस टीथ इन 3D व्यू. So this is actually the structure of this teeth such that this is called as profile. This portion is called as the top land and this width is actually called as the face width. So this is actually a 3D tooth structure. So it is consisting of the following portions. We have the profile, then we have the top land and we have the face width. So this was all about some basics of gears. Now we come to a very important point, that is classification of gears. Now the classification of gears is done accordingly to the following criterions. The first criteria is according to the axis of shaft connected. According to axis of shafts connected. Actually in this diagram there will be a shaft corresponding to this gear and the shaft corresponding to this gear also. Okay, so they are mounted on these shafts and depending upon the orientation of these shafts the gears are classified. So for example, when the first is when both axes are parallel. When both axes are parallel to each other like this. Okay, since these two axes are parallel to each other, then pure rolling motion can be transmitted between the two cylindrical surfaces in contact. Here pure rolling motion can be transmitted. Pure rolling motion can be transmitted between the shafts or between the two cylindrical surfaces in contact. This is very important point. Here two cylindrical surfaces are used to transmit power or motion between them. So, and the characteristics of the teeth here will be teeth are straight and parallel to the axis of rotation. So here the teeth are straight and they are parallel to the axis of rotation. For example, this is one body or one gear and the teeth are like this. The second one is like this. Okay, such that the axis of the first gear is this and the axis of this gear is like this. So these axes are actually parallel to each other. Okay, and these gears are actually 99% failure and only 1% are used, and that too for power transmission at low speed. These are actually used for power transmission at low speeds. Okay, the advantages of such types of gear observed was there was no axial thrust. There was no axial thrust of force. Force का कोई भी axial thrust यहाँ पर नहीं था. Okay, but जो disadvantage यहाँ पर देखा गया, there was instantaneous engagement and disengagement of the teeth. मतलब instantaneous मतलब झटके में ठर 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 ठर, मतलब इस टाइप का देखिए कुछ स्ट्रक्चर होगा. ये जो गियर ऐसे फंस के ऐसे चलेंगे, तो यहाँ पर जो engagement है, so in such type of gears there was instantaneous engagement and disengagement, and hence they were 99% failure, and only 1% was used in the transmission of power, and that too at low speeds. And such type of gears were used in case of wrist watches. So if you are asked, the type of gears which are used in the wrist watches are those gears in which the teeth are parallel to each other and the axis the teeth are straight and the axis is parallel to the axis of rotation. ठीक है, तो ये हो गया हमारा about the teeth or about the first type of gear. Now because of this we had one more disadvantage, that it was consisting of impact stresses on the profile portion. There was impact stresses on the profile portion also. So disadvantages were many. The advantages was that it had no axial thrust. Now the second type of gear that we are going to discuss. तो ऐसे gears का जो नाम दिया गया, such types of gears were known as spur gears. Such type of gears were known as spur gears. तो spur gears हमें याद रखना है कि कहाँ मेन इनका एप्लीकेशन होगा. The other types of gears were helical gears. Helical gears, and in case of the helical gears, the teeth were straight but they were inclined to the axis of rotation. So based upon their and it was further divided into two categories. One was the right-handed helix and the other was the left-handed helix. So in case of the helical gears, the teeth are straight but they are inclined to the axis of rotation, and hence they are categorized into right-handed and left-handed helix, such that always the opposite hand helical gears must come in contact. So here what was the advantage was, in such type of gears always the opposite hands of the helix were made in contact, and this actually led to the gradual engagement. Whereas in the previous case of spur gears we had instantaneous engagement and disengagement, but here the advantage of gradual engagement was achieved. That means the right-handed helix must be in contact with the left-handed helix, and this resulted in the gradual engagement with no impact stresses. There were no impact stresses, so this was also an advantage. Impact stresses were in the profile in case of the spur gears, but now the impact stresses have also been removed. So they were 98% of use. Okay, they are generally used in cars. Okay, they are generally used in cars. But the disadvantage that was found in such type of gears, I will draw the diagram. These are the teeth. They are actually inclined to the axis of rotation. This is body number 1. This is body number 2. Okay, this is 1, this is 2, such that we had this force and this force. So there was axial thrust. So we are having two advantages, that is gradual engagement, and along with gradual engagement we have no impact stresses. But here we are having a very great disadvantage, that is axial thrust is there. Thus, in order to minimize this axial thrust, it was again modified to double helical gears. So we now saw that the first category was spur gears, where the teeth were straight and parallel to the axis of rotation. The next category we got helical gears, where the teeth were straight but they were inclined to the axis of rotation. Now again an advanced version of helical was double helical gear. Double helical gear. And in case of the double helical gear, they are also called as herringbone gears. So double helical gears are also called as herringbone gears, and the diagram of herringbone gears would be somehow like this. This is actually some space is being left out. And this space is actually called as the tool run out space. This is actually called as the tool run out space, such that this was F, this was also F. They were free from axial thrust. they were free from the axial thrust, but they were only 1% in use, and that too they were used in the racing bikes. They were used in the racing bikes. Okay, very high speed application bikes they were used, and this space is called as the tool runout space, and we will see that these two F's will actually cancel out each other. So they will actually cancel out each other because their component will be along this line and they would both be cancelling out each other. So in reality we see that these gears are very costly, and hence they are used in the racing bikes, and that too very high speed racing bikes. So this was the third classification or the category of gears. Now the fourth category of gears were when the axes were intersecting. When the axes were intersecting, for example, one axis was like this and the other axis was like this. So actually what we had is so the body or the gears were like this, such that both their axes were intersecting. Say that this is body number 1 and this is body number 2. So the common line that you can see here, it is actually called as the generating line. It is also called as the generating line, and such type of gears in which the axes were intersecting, they were called as the bevel gears. Such gears were called as the bevel gears. Here the pure rolling motion can be transmitted between the two conical surfaces. These are actually conical surfaces which were in contact, and these bevel gears are further classified into three categories. These bevel gears were further classified into three categories. One was the straight bevel gear, the other was the zero bevel gear, and the third was the helical bevel gear. So in the straight bevel gear and in the zero bevel gear, they are almost same. They are almost the same. Whereas helical bevel gear, we again have two parts, that is the right hand helical and the left hand helical gear. Okay, so these bevel gears are actually used in automobiles. Okay, so bevel gear was again classified into straight bevel gear, zero bevel gear and helical bevel gear, and the helical bevel gear is further classified into the right handed and the left handed gears. And there is one note point, and the note point is that the spherical bevel gears, their spherical bevel gears are used for differential mechanisms of automobiles. So spherical bevel gears are used in differential mechanisms of automobiles. Okay, so they were used in the differential mechanisms of automobiles. So it may be asked in the 1 marks question, which type of gears are used for the differential mechanism? So we would say they are spherical bevel gears. Now we can see we will see one condition when these axes would be intersecting at different angles. So here we can see that the axes are actually intersecting at 90 degrees, and these two gears are actually similar. How? In the diagram they may not appear to be similar, but actually they would be similar, such that this is body number 1, this is body number 2, and omega 1 upon omega 2 is equals to 1. Then they are called as mitre gears. They are all called as mitre gears. Whereas if these two cones became dissimilar, then omega 1 upon omega 2 will not be constant, but they would not be equal to 1. So it should be equal to 1 in order to make it as mitre gears, and mitre gears are those type of bevel gears in which the shafts are intersecting at 90 degree, and these mitre gears are used to connect they are used to connect governors to the engine so that the governing process becomes easy. They are actually used to connect the governors to the engine so that the governing process becomes very easy. The fifth type of gear that we'll be discussing is when both the axes, they are neither parallel nor intersecting. So neither parallel nor intersecting. So when the axes are neither parallel nor intersecting, then such type of gears had the following features. Pure rolling is impossible. Here the pure rolling is impossible in such type of gears. The second is rolling is possible but along with partial sliding. Here partial sliding plus some rotation will take place, since pure rolling is not here. So here actually sliding is taking place in the direction which is perpendicular to the direction of motion. So this is a very important point. Sliding is actually taking place perpendicular to the direction of motion. Perpendicular to the direction of motion. Okay, and we see. So I will draw the diagram corresponding to that. Okay, so here there will be lines like this. Okay, and this angle is called as the spiral angle. This angle is called as the spiral angle. This is the axis and this surface is actually called as hyperboloid. This surface is called as the hyperboloid. And here the generating line is a skew line. Generating line is a skew line which is neither parallel nor intersecting. This is neither parallel nor intersecting lines. Then such line is called as the skew line, or it is also can be commonly called as hyperbola. Okay, so here we are not having pure rolling but partial sliding along with rotation, and such type of gears will be called as spiral gears. Such type of gears will be called as spiral gears or skew bevel gears. So here the generating line is not a line, actually it is a hyperbola type of shape. And where they are used, very important application of these gears is when the space between the two shafts, that is there is some offset between the shaft and this offset is very less, then some portion of the hyperboloid is used to form the spiral gear, such that it is called as the hypoid gears. So actually hypoid gears are used to when there is some space or offset between the shafts, then some portion of the hyperboloid is used to connect them. Okay, so they will be generally used during space limitation. They will be used during space limitation. Okay, so this was all about spiral gears. Now we come to worm and worm wheel. Worm and worm wheel. Now worm and worm wheel, इसमें जो हमारा worm होता है, it is actually a smaller body, and the worm wheel, it is actually a larger body. Okay, and worm is having very high spiral angle and low diameter. High spiral angle and low diameter, whereas the worm wheel is having low spiral angle and very high diameter. Since worm wheel is very large, so diameter will be definitely large, and diameter is large, that means spiral angle is low. Now these gears became very famous for very high speed reduction ratio. So these gears were very famous for high speed reduction ratio. And speed reduction ratio, for example, 10:1, 30:1, 100:1, 300:1, 1000:1, 1250:1. This actually, the left hand side data is for the worm and the right hand side data is for the worm wheel. And please remember, their driver is only worm. The driver is only the worm gear. What do we mean by the driver? We simply say that one of the bodies will be a driver and the other body will be a driven. So worm is always the driver in case of worm and worm wheel. Okay, and worm wheel, why it is always a driver? It is because the worm wheel cannot overcome the static friction of the worm. Okay, and that is why the driver is always taken as the worm. And where these are used, I will tell you a very interesting application of this worm gear. They are used in the strings of the guitar. The tensions in the strings of the guitar are maintained by means of the reverse locking arrangement which is provided by the worm and the worm wheel. तो जो हमारे गिटार की स्ट्रिंग्स में टेंशन मेंटेन की जाती है by reverse locking arrangement, that is actually being maintained by means of worm and worm wheel. Okay, so ये बहुत important इसका application था. Now we come to the classification of gears according to the type of gearing. Type of gearing. तो gear में जो एक होता है हमारा, एक होता है ड्राइवर बॉडी, एक होता है एक्चुअली ड्रिवन बॉडी. और जो ड्राइवर बॉडी होती है वो ज्यादा ओमेगा से घूमती है और जो ड्रिवन बॉडी होती है वो नॉर्मली कम ओमेगा से घूमती है. ठीक है. सो टाइप ऑफ गियरिंग, द फर्स्ट टाइप ऑफ गियरिंग इज external gearing. So in case of the external gearing, what will be observed? The gearing would be done in such a manner that the teeth are actually in contact externally. This is the center of the first gear, this is the center of the second gear. It is rotating in this direction and it will be rotating in this direction. So if we draw the side view, this can also be seen like this. This is one of the gears, this is another gear, and we will draw the shaft corresponding to this, shaft corresponding to this. Okay, so this is gear number 1, this is gear number 2, and at this point we are actually having the engagement between the teeth of 1 and 2. And please mind that in case of the external gearing, if this is rotating in the anti-clockwise sense, the other would definitely rotate in the clockwise sense. So both are rotating in the opposite sense. Both rotating in opposite sense. Both are rotating in the opposite sense in case of external gearing. And the bigger one, the bigger wheel is actually the gear and the smaller is called as the pinion. Oh, I told you wrong. जो हमारा bigger wheel होता है इसको हमेशा gear बनाते हैं और smaller wheel को हम लोग पिनियन बनाते हैं. और स्मॉलर व्हील का क्योंकि ओमेगा ज्यादा होता है तो दिस इज मेड एज द ड्राइवर एंड दिस वुड बी मेड एज द ड्रिवन. ये चीज प्लीज करेक्ट कर लीजिएगा. ड्राइवर जो होता है वो छोटा वाला व्हील होगा और जो हमारा ड्रिवन होगा दैट वुड बी द बिगर गियर. नाउ वी कम टू द इंटरनल गियरिंग एंड इन केस ऑफ द इंटरनल गियरिंग द सेंटर्स ऑफ द गियर, सेंटर्स ऑफ गियर मे बी सेम और डिफरेंट. हो सकता है कि दोनों के सेंटर जो हो सेम भी हो सकते हैं या डिफरेंट भी हो सकते हैं. द अदर इंपॉर्टेंट फीचर ऑफ इंटरनल गियरिंग इज दैट बोथ विल रोटेट इन द सेम सेंस ऑफ रोटेशन. Okay, so in case of the internal gearing, the sense of rotation would be same, whereas for external gearing, the sense of rotation would be different. So this is a very important feature that we need to definitely remember. And if more than one gear are mounted on the same shaft, for example, if this is a gear which is being mounted on a shaft and one more gear is mounted on that shaft, so if more than one gears are mounted on the shaft, then they are called as compound gears. They are called as compound gears. And one important feature of the compound gears is speed will be same for both. Speed would be same for both the gears which are mounted on the same shaft. And generally the smaller bodies are made pinion or the drivers. I have already told you, I made a correction. I actually accidentally told you something wrong, but the correction is the smaller bodies are generally made as the drivers for power transmission. Why? Because they can rotate at larger omega. Omega for the smaller bodies would be large, and since they are small, the number of teeth on their external surfaces would be less. Okay, and hence they are generally used or made as drivers for the power transmission, and omega is large and the teeth are less. So with this we come to the end of this lecture. In the next lecture we shall be continuing from here onwards. We hope that you people are enjoying our lectures. Keep giving us your valuable feedbacks, and also share your problems with us on our YouTube channel or on our Facebook page. You can search us on Facebook also, and do tell about this channel to your friends and to your colleagues so that they may also be benefited, because everything is available absolutely free on this channel. So thank you so much.